Okay, everybody. So today we're going to be talking about Chapter 7 on climate change, which hopefully by now you know is a pretty big deal on the Earth today. And there's lots of videos in the Chapter 7 module, the weekly module, a lot of them having to do with kind of the politics behind climate change. But make sure you watch all those, okay? Again, very, very important topic. And the first part of the lecture, we want to look at how we know the climate's changing, and the book goes into this in a lot of detail. So I'm just going to cover it kind of briefly here. Okay, so what we do is we look at evidence from the past, and that will give us some idea of what the climate was like, thousands of years ago, and sometimes hundreds of thousands of years ago. We can look at fossil plankton, gas bubbles and glacial ice, ocean, lake bottom sediments, pollen, fossil pollen, growth rings in trees is very common, and mineral formation in caves and corals. Now, these aren't direct measurements. They're what we call proxy measurements that we use as um, uh, evidence of what the past climates were like all these many, many years ago. So these materials that they're deposited year after year, okay, and scientists extract these through what we call usually core samples, where there's sediment from the ocean and lakes, ice cores, for example, or we can recover them as fossils and use isotope analysis. Um, this is from your book, but it's give you some idea of this is in Greenland, the snow pit. You can go down. They dug the extra took this out and gives you some idea. You can see the different layers. In this case, sample from the ice core, and if you look carefully, you can see the tiny bubbles of air, and you can actually measure those, and it gives you an idea of the atmospheric composition back then. So it's very simple. It's just we know that O16 in water evaporates as it falls as snow, and it's stored. But in the ocean water, it's what we call the low ratio of O16 to O18 in the oceans. And by comparing the two, it gives you some idea of whether the climate was colder or whether the climate was warmer. The book will go into this in a little more detail than I'm going to do it here, but read that carefully. It's just another way, by comparing the two, it'll give you some idea of whether the climate was warmer than today or colder than today. So you can reconstruct the climates from 70 million years ago, and by looking at how those change, it gives you some idea of what we're looking at today. Now, what is very important is in the last 5 million years, that's the evolution of modern humans. And that also includes the rise of agriculture and civilizations, and also the Industrial Revolution. Okay, so basically over that period of time, in the recent time of humans on the earth, we've had an ice age where we had cold climates that include glacial periods. Then we have these glacial retreats, and the last one of these was about 2.5 million years ago, the Pleistocene epoch, where we had glacial activity about 2.5 million years ago, and that lasted in geologic time very recently, to about 12,000 years ago. So 70 million years ago, there was rapid warming, then cooling, climates, the tropics were extended, then it cools down from about 50 million years ago, all kinds of reasons. The predominant theory is that carbon dioxide was absorbed by the newly formed Himalaya mountains, which we'll look at this in when we get to Chapter 8, when we look at tectonic activity, how the Himalayas were formed. Then about 56 million years ago, we start warming again. Most people think that was because of atmospheric carbon and increase of that. We melting methane in the ocean and so forth. Then about 5 million years ago, we saw very fluctuating temperatures, series of warmer and cooler periods. About 125,000 years ago, temperatures were very similar to ours. Carbon dioxides were lower, but temperatures were warmer. So this is from your book, so you can get a better idea. But when you look at it in the book, but this gives you some idea of what the climate is doing. That's 500 million years ago, and just thousands of years before present, and here's the present. So it goes through these very distinct periods of warming and cooling. So notice how warm it was way, way, way back then, and it's a little baseline 0. So here's 0 over here. So it was pretty much a lot warmer for a big, long period of time. Then it got colder, and then it's back up to where it is today. Okay, so stop here, and then we'll do the how we reconstruct these short-term climate change models, okay, in part 2.